Hello, my name is Monica Gross. Welcome to Unit 1's direct instruction on perpetual motion. During this presentation, we will look at the definition of perpetual motion, learn why we should care about it, and analyze the laws that govern the universe, and conclude whether or not perpetual motion is possible given these laws. What is perpetual motion? Perpetual motion is motion that continues without any external source of energy. Why should we care about perpetual motion? If a machine could be set into perpetual motion, it would mean that it could work indefinitely without the need of an input of costly fuels. This would mean that we could get to work without the need for gas. We could heat our homes without electricity or natural gas. Much of the pollution in the air and the gases that contribute to global warming would no longer be produced. In the coming slides, we are going to try to analyze the laws governing the universe in order to see if perpetual motion could be possible given these laws. First, let us consider Newton's 3 laws of motion. Newton's first law states that if an object is at rest, it will stay at rest, and that if an object is in motion, it will stay in motion at the same speed and direction unless acted upon by another force. An object in motion is supposed to stay in motion, but there are multiple forces, including friction, that act against motion to cause an object to decelerate. Friction is the resistance between two surfaces. Air resistance is an example of friction. A plane must move through particles of air. The particles in the air push against the plane as the plane pushes against the particles in the air. What about in outer space? In the beginning, there was nothing. Then, when the universe began, there was a giant explosion of matter and energy. The gravities of large masses of matter attracted other bodies of matter so that galaxies and solar systems formed. Are the orbiting planets and moons examples of perpetual motion? The planets and moons would seem to be in perpetual motion since they have been in motion for billions of years in what would appear to be empty space. However, there are processes in space that dissipate the kinetic energy of celestial objects, including solar wind, interstellar medium resistance, gravitational radiation, and thermal radiation. Given this example, perpetual motion seems impossible because it shows that even in space, there are forces that act against perpetual motion. The electrons of an atom move around its positively charged nucleus, much like the satellites of the sun. Do electrons move indefinitely around the protons and neutrons of the atom? If so, then perhaps this could be an example of perpetual motion. It does not appear that their energy of motion is reduced over time. What do you think? When you think about radioactive elements, they do decay over time. What about more stable atoms? What about Newton's second law? It states the acceleration produced by a net force on an object is directly proportional to the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. In other words, when a force is applied to two objects with different masses, the object with lesser mass will accelerate more. Acceleration requires a change in direction and/or an increase or decrease in speed. By definition, perpetual motion is a motion that does not change. So this law will not help us in solving a problem about perpetual motion. Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. In the picture shown here, one sphere exerts a force on a second sphere. It would seem that they would perpetually bounce off one another, since the law states that each exertion is equal and opposite. However, each subsequent collision is slower than the previous one. What happens to the kinetic energy? What slows it down? The mass of the spheres absorbs some of the impact and is converted to vibrations, sound energy. Air resistance also dissipates energy. Can you think of another or of other forces that reduce the energy of motion? How could any motion exist without a force producing the energy to push it? With this in mind, we must also consider the laws of thermodynamics. The first law, also known as the law of conservation of energy, states that energy cannot be created or destroyed in an isolated system. The second law of thermodynamics states that the entropy of an isolated system always increases. Consider the first law of thermodynamics. Remember, energy cannot be created nor destroyed. Therefore, energy of motion, or kinetic energy, must be produced by transformation of another type of energy. If this energy is not constantly renewed, the motion will decline and stop. Wind power serves as an example to show energy transformations. Wind turbines get their energy from the wind. The wind is kinetic energy, the energy of motion, that evolves from differences in temperatures in the atmosphere. These differences originate due to thermal energy from the sun. The energy of the sun is generated by nuclear fusion in the core. Once the wind turns a turbine, the kinetic energy can be used to generate electrical energy. Consider the second law of thermodynamics. Eventually, the energy from the wind turbines is converted to electrical energy, and the electrical energy is used to do work. Much of the electrical energy is released as unused heat, as in the case of light bulbs. Heat is difficult to harness as it diffuses through a room. Heat has the tendency to diffuse out from a concentrated area to become less densely packed. This unordered state is called entropy. The laws of thermodynamics show that energy can be transformed but not created or destroyed. Without energy, a system moves towards greater entropy or disorder. The definition of perpetual motion states that it must occur without energy, and we have learned that this is impossible. Energy is required to keep a complex or even a simple system moving or in motion or at work. The human body is another example of this. We use the chemical energy found in food to nourish our bodies. Without this constant supply of food, our bodies would stop functioning, leading to the breakdown of cells and the end of life. Without energies, our bodies become disordered, dead. Obviously, this is a state of entropy when compared to the complexity of a living body. From this presentation, you learned about Newton's laws and the laws of thermodynamics and how they affect matter and energy. I'd like you to analyze what you've learned to formulate a conclusion of your own in order to address the prompts for Unit 1 discussion. The prompt asks, according to the law of motion, is perpetual motion possible? Please explain your answer by discussing Newton's 3 laws of motion. Make sure that you provide a specific example that best describes or explains your answer. Remember to consult the rubric in the faculty and course information section and respond in 250 to 350 words. Respond to your classmates' posts. Please understand the amount of work required for this week. Besides your introduction and this discussion, you must also complete your lab assignment, the discussion forum for the lab assignment, and your 2 essay questions. Have an excellent week, and please let me know if you have any questions. Bye-bye.